Hello and welcome to another episode of Smokey and the One-Armed Bandit. In today's episode, we're going to be looking at the rear end of the car, figuring out a stronger, more reliable setup than the original stock gear that we had in the 325. I've got half a plan, I've got half the parts, and I'm probably way too financially committed to this, so let's go see what I've got myself into. So I will say before we get too deep, this is going to be a pretty technical episode, probably will be quite long. We're going to be really taking a look at the complexities of doing this swap. I really want to give people the opportunity to have a lot of the information that they need to do this themselves. So before I show you what I've got myself into, I thought I might talk about it for a couple of minutes, give you my thought processes on why I've gone down this path. Basically, I need a diff, axle and hub setup that is going to support the power that I've got reliably and without me having to constantly worry about it or change out parts. So looking into it, basically I think the stock gear, the 325 gear, isn't really going to cut the mustard. It might last a little while, but eventually it's going to break and I don't want to be having to worry about changing parts over at the track. So that's out pretty much before we've started. If it was a daily, I'd probably risk it, but being a track car, might go interstate. Don't want to have to think about it, want to have it reliable from the outset. So that's out. The 330 gear, the 330i, bits and pieces. The axles are a bit stronger. The hubs are definitely stronger with the splines on it because they've got a bigger spline on the 330 and a bigger wheel bearing. But I'm probably going to run into the same issue. Don't want to have to worry about it. So I'm going to not worry about them from the outset. The next obvious choice is going to be the M3. So the M3 is quite a lot stronger. It's got 210mm, I think it's crown wheel, and axles are quite beefy, and it seems like a really good way of going. Problem is, parts are really hard to get. If I broke something at an event, trying to get parts like an axle or a diff to replace it is going to be quite difficult, and they're really quite expensive. When you look at it, they're $2,500, and you got to do the subframe, all the arms, it's all specialty M3 bits and pieces. So I don't really want to go that way either, because I want to be able to have a parts that I can get from a wrecker without having to worry, or get from someone that supplies to drifters quite easily, or even from other competitors. If other competitors have spares, being able to grab their bits and pieces, chuck them in my car and go. And I'm not going to be able to do that with an M3 rear end. So it became pretty clear pretty quick that a bolt-in option wasn't really for me. None of the options really tickled my fancy, and I was going to have to go more of a custom option. So I looked around. The Americans seem to really love their 8.8 Fords. I think they come out of a Ford Explorer. The problem is, although we did get some of them over here, there's not that many of them, so parts wouldn't be that easy to find. And they're also quite old, so all the parts are going to be quite old. So looking at that, not really the option that's going to work down here in the land of the kangaroos. Although I think if I was in America, that probably would be the way that I went. You can buy kits for them over there that bolt straight in, but they're quite expensive, so it depends on which way you want to go. The next option that came to me quite naturally was maybe I can get a Commodore diff into the back of the E46. Obviously it's got a Commodore engine, Commodore diff would make sense. That probably would make sense, except I don't know anything about Commodores, I don't know about the parts or where to get them, I don't have many friends that have Commodores, so it wasn't really a realm that I was confident in. So I thought, maybe that isn't quite for me, and I looked around for other options, and I came across the option of 350 or 370Z. And I have actually spoken to people online and on Facebook that have done it before, so I did at least know that it was possible. They didn't have a whole lot of information to give me. Usually it was someone else put it in the car and then they bought it. But knowing that someone had actually done it before gave me a lot of confidence. Parts wise, they still make 350Zs, so you can buy brand new parts right now if you need to. There's going to be a good stock of them for a long time. They're quite strong. They're very equivalent, at least the 370Z stuff is very equivalent to Gtr rear ends, which is another thing I looked at, but Gtr stuff is very expensive, so I didn't really go that way either. So it looked to me like 350Z and 370Z was the way to go. Also because you can just go to pretty much anywhere that's drift related, drift event, and get Nissan parts, I already buy Nissan parts for this thing. I'm already in that world, so it all makes sense to me. So I went into that, did a bit more research, pretty much came to the conclusion that the 370Z stuff is the stuff that you want. Could put 350Z stuff in it, but the manual ratio is 3.5, whereas the ratio for the manual 370Z Diff is 3.69, which is very similar to the 3.7s that came out with the LS. So I thought that would probably be the best way to go. They've also got stronger axles. They've got GTR splines on them and use basically GTR splines in the hub. Around here you can get them reasonably cheap. I think I picked up diff, axles and hubs for $900. So I've got those parts here. Now I just need to figure out how I fit them all into the car. So Dad's actually hard at work welding on the rear cross member at the moment, rear subframe. So we'll talk about this stuff instead, which is all this 370Z stuff. So you can see here you got the two mounts at the front and one at the rear. And I got axles and hubs and other bits and pieces that I need to figure out how I'm going to make it work. But for the moment, I'm just going to focus on fitting the diff into the rear subframe, see if we can get that all happening and then work out from there. So Dad's gone inside, thought I might grab the subframe and mock it up with the diff just to show you guys what's been going on. We can see here that we've cut out a pretty decent amount of metal on either side to fit the front of this diff through. This is the original bush. That used to sit down there, and obviously the bolt went in that way. Now that we've got the 350Z or 370Z diff, the bolts are going to have to go up through it, and we're going to have to build some kind of plate up here that's appropriately strengthened so that the diff can bolt against it. Drilled through the bottom of the subframe and put these tube. That's just going to mean that it's nice and easy to get this bolt to go through there and into there and be able to get a tool onto it to tighten it up and undo it. So that's coming along reasonably well. Got a decent amount more boxing to do to make it strong enough, but I'm pretty happy with it. On this side, we've just basically gas axed off the old mount for the old diff, and we're just going to need to build something that connects to this stud down here. That shouldn't be too difficult. I think it's mainly the front here that's going to need most of the work. The back end looks reasonably simple to do. So we're back in the shed. It's been about 3 months since I shot anything for the rear end conversion. Basically, it just got too difficult to try and film everything as we did it, because we'd try something, it wouldn't work. Would have to go back to the drawing board, then try something else. So figured I'd wait till everything was together. I got all the bits and pieces on me, and would basically just film everything going into the car. So we'll start out with the subframe behind me, and then we'll move on to the hubs and other bits and pieces that went with the conversion. So here's the completed rear subframe. You can see there's quite a bit of work from when we saw this a couple of months ago. In particular, this top section is now completed, so it holds the diff in place. That's boxed in there, a bit hard to see, but yeah, it's boxed in there reasonably well, so we're pretty happy with the strength of that. Like I showed you before, the bolt comes through the hole just in the bottom of the cross member there that we put, and goes up into the diff and then into the subframe. So you can probably also notice there that we've hard mounted or solid mounted the diff into the subframe, so we've got rid of the rubber bushes that were originally there. So we're really happy with how the front turned out. And then if we come around to the rear, and here we are, this is the rear mount for the diff that comes out of the single stud in the diff hat. And we've just got this spacer on there at the moment, just so we don't have to keep tightening up the stud all the way, but that'll disappear when it's mounted in for the final time. This rear mount is actually made out of 2 bits of steel, so you can see the bottom one, the lip of the bottom one there, and then you've got the outer one. And you can probably also see it when you come around this way. So there's an inner and outer to provide a bit of triangulation. And yeah, so that's nice and strong. We're quite happy with how it turned out. Things you'll have to keep in mind if you're going to do this yourself is making sure that you place it in a spot in the rear of the car that's actually going to work and not foul on anything. We had ours slightly too far forward, so it just tapped ever so slightly on the car just here. And I'll just show you where that is on the actual car. You can see we've flattened it down. It's just there we've flattened down to make it all work, which isn't really an issue, but something to keep in mind. If you went too much further forward, you might have more issue. And then things like making sure there's enough room in between this rear stud and the back of the wheel well for the spare tyre. So those are things that you need to keep in mind, as well as things like pinion angle. If you're not sure what pinion angle you should use or how to measure it, have a look online, but also go speak to the person that's going to be making the tail shaft. They should be able to give you a good idea. It's going to depend on which gearbox you're using, how you've placed it, and all those sort of bits and pieces. So it's going to be fairly unique to you, so you want to make sure you get it right. Otherwise, yeah, this is all done. It needs to be painted at some point, but it's just a test fit at the moment. So we'll move on to the other bits and pieces that are a part of the swap. Dad's testing Casper's trust. So that's the subframe all done. Now we're on to the second major hurdle of this conversion, getting a Nissan hub inside an E46 trailing arm. So it's not necessarily an easy thing to do. There is definitely a fair bit of machining involved, but before we even get to that part, we need to make sure that we've got the right parts, whether we're going 350Z or 370Z, because the corresponding parts are actually quite different for those, depending on which axle and hub setup you want to use. So what I'll do now is I'll probably put some graphics up on the screen, try and explain it that way, because it's all reasonably complex, and I'm probably going to struggle to do it just holding the camera in front of my face. So I'll pass it over to narrator Tate and he can take it from there. Narrator Tate just dropping in here to quickly give you the differences between using a 350 and a 370Z axle. The top section and the bottom section are actually divided up by the axle, not the diff itself. I'm not 100% sure on this, but I do think that you can probably swap the diffs out and it won't make a difference whether you use 350 or 370Z, but the axles are definitely going to make a difference. So listen up, try not to fall asleep. This is going to be very helpful if you're going to be doing this swap. Before we get too deep here, I just want to quickly mention the main overarching difference between these two axles, and that is that they have different output splines that go into the hub. The 350Z has an S13 style spline, while the 370Z has an R32 GTR style spline. So the GTR spline is larger and stronger than that of the S13, and it does make differences in things like wheel bearings when doing this swap. So with that in mind, let's get into the detail of the 350Z and how we might go about fitting that in the car. So taking a little bit of a deeper look at the 350Z axle options, obviously we're going to need the axles themselves, but we're also going to need 328i or lower spec rear trailing arms and also wheel bearings. So 325i, 320i or 318i should all work because they all run a wheel bearing with an ID of 42mm, which is what we need. Then we also need a hub. We can use the 350Z standard hub as this is a unit that can be pressed out. We can also use S13 to S15 or Skyline GTS-T hubs. So it should be noted that the 350Z axle is actually shorter than the 370Z axle. I'm not sure exactly how much, but I have heard about 10mm. So keep that in mind. It may mean that you need to run a spacer, and if you did run a spacer, you might be able to machine a little less of the splines off it, so it may make that a little bit stronger. The second note that I've got basically tells you the difference in internal diameter for the wheel bearings in between the two cars, and from that you can deduce how much you need to machine off the Nissan hub. The pros of using a 350Z axle setup are basically that it's easier and cheaper to source parts. Both the Nissan and the BMW parts we're getting are from lower spec cars, so there's a lot more of them and they're a lot easier to get their hands on. The cons are that we're using weaker axle splines compared to that on the 370Z, and obviously it's going to be more prone to breakage. So that's enough chit chat about the 350Z. Time to talk about the 370. Obviously again we're going to need axles. We're also going to need 330i rear trailing arms and wheel bearings. This is because these cars actually run larger wheel bearings than the rest. They run the same size as the M3, which have an internal diameter of 45mm. We're also going to need a Nissan hub, but we can't just get any normal Nissan hub. We need to get one from a GTR. So R32 all the way to R34 should all work and be able to be pressed out. The reason that we need the GTR hubs is because the 370 and the GTR both run a larger diameter, more heavy duty spline, and because of that we need a bigger wheel bearing, which is why we need the 330i gear. The notes I have for this swap are that the 370Z hub cannot be used as it's not possible to remove it from the wheel bearing. They cannot be pressed out. We tried, it didn't work. The only way that you can get them out are machining them out, but the time and effort required to machine them out, as we figured out, definitely wasn't worth it, and would be much better to just go buy Gtr hub, which can be pressed out quite easily. The second note that I have is that we did buy some non-genuine Gtr hubs for this swap. They were GSP branded, but we found them to be terribly machined. The splines had a lot of slop in them compared to the OEM units, and we were very unhappy with how that they were done, so we decided not to use them. We actually bought two of them. We had one machined up, and you'll see them in a moment when we're talking about the machining, but that's the reason that we basically didn't use them. The third and final note that I have is just the difference in internal diameter between the wheel bearing on the 330i and the Nissan GTR. As you can see, there's a millimetre difference there, so that millimetre will need to be machined off the Gtr hub. The pros of using the 370Z axles are that the car's still in production, so there's going to be longer parts availability. Also, the stronger axle splines mean that the car's going to be able to take more abuse without breakage. The cons are, the parts for this axle setup are more expensive to get and more difficult to get. The 330i rear end is obviously going to be more difficult than getting a lower spec model. And the GTR wheel hubs are also going to be quite difficult to get compared to standard 240SX or S13 rear hubs. Well, hopefully you're still with us. My voice hurts though, so I'm going to hand you back over to the other Tate. So we're back in the garage now. I know that was a lot of information to take in, but it's pretty important stuff if you're doing this conversion. I know it took me a long time to get all that information together and figure it out. I bought parts that I didn't need and spent time that I didn't need to spend to get to that stage, so I'm glad you guys won't have to do that. Of course, with all the information on this channel, take it with a grain of salt, do your own research, particularly the 350Z side of stuff. I haven't really been able to confirm it because I don't have the gear here. So yeah, take it with a grain of salt, do your own research and come to your own conclusions, but hopefully this is a good guide for you guys. So now we've got all the gear. Obviously I went 370Z, so this is going to be slightly different for those that do go 350Z. But I think most of it, the vast majority, is going to be pretty similar. So we'll jump down into the bench here. I've got a couple of dummy hubs that we had machined up that should give you guys a good idea of what we needed to do to get this all done. So here's our test hubs. On the left we've got a standard GTR hub that's going to suit the 370Z spline. Next we've got the same thing, but this one's been machined down to fit into the BMW trailing arm. And finally we've got this BMW standard hub. So I'm going to go through the different aspects of the machining that needed to be done to get them in there. But basically the long and short of it is you need everything from this face to this face of the BMW hub to be the same but replicated on the Nissan. So with that in mind, we'll jump into the first part of the machining process. So I will quickly make note that this machined down Nissan hub isn't quite accurate to the one that's in the car. It's actually about 4mm too high. We were trying a couple of different heights, but ended up going with a standard offset for the rotors to still fit. But in every other aspect, it's the same as the one in the car. It's just 4mm longer. So the first part of the machining, we need to make sure that the hub has the same offset as on the standard car. So how we do that is we machine down where the bearing sits against until this face and this face are the same distance as on the BMW hub from here to here. The reason we need to do that is we need to make sure that the rotor and the caliper have the same spacing so that everything can just slide straight on and not have any issues, not having to use any spaces for the caliper or spaces for the rotor. So we've done that on the ones on the car, and it means that we should be able to, once we've re-drilled the holes in the rotor, just put the brakes on, the standard BMW brakes, and everything should bolt straight on. Step 2 of this machining process, we need to machine this face so it's the same distance from here to here as the BMW unit. And you can see we've done that on this already machined one here. It's quite a bit shorter from here to here than the standard GTR. The reason for this is we need to have preload on the bearing, and we also need to have the bearing and the hub bolted together by the axle. We'll go through that in a little bit more detail later on, but that's essentially why we do it. And yeah, you can see this is quite a lot shorter than the standard one because we've had to match it to the BMW. Step 3 of the machining process, basically what we need to do here is replicate the spacing between where the splines start and where the top of the hub is, but on our machined hub. The reason for that is, as we machine this down, it meant that the splines essentially come all the way to the top of this ring, and we can't have that because if you look at the axle, there's actually a spacing between where the splines start and where this face is, what the hub's supposed to sit against. So we need to replicate that so that this hub won't get caught at the end of the splines, and we'll be able to go up and pretty much meet up with this surface here. Not quite, because obviously it's supposed to meet up with the bearing, but it's got to be fairly close to that. So we've machined out the inside there and got the appropriate spacing, so that shouldn't be an issue. So now we're up to step 4. What we need to do is machine the Nissan hub to be the same outer diameter through this part as the BMW wheel bearing we're going to use. So this is one of the main measurement differences between the 350 and the 370Z. I'm obviously doing 370Z gear, so I've got a GTR hub, and I'm going to be machining it from 46mm diameter to 45, and just taking 0.5 mil off on the machine as we spin it around, and that'll end up giving me a total of 1 mil across from here to here. We've got that done. That means that we can put it straight into our 330i wheel bearing, and obviously you'll need to speak to the machinist to make sure that he does an interference fit. You obviously can't have it so that it's going to be slightly smaller, because you need that to be nice and tight inside the wheel bearing. So make sure you speak to him about that when he does it, and make sure it's an interference fit. Otherwise, you're going to have to go and get yourself a new hub. So keep that in mind. But yeah, that just needs to be the same size as that, and we can fit it into our wheel bearing. Step 5 of the machining process, we need to machine down this lip here, because at the moment if we tried to put that in, what would happen is the trailing arm would actually hit against this. The part that holds the wheel bearing and also holds the circlip for the wheel bearing is going to foul on this part, and you're not going to be able to spin the hub nor get it all the way into the wheel bearing. So what you need to do is basically just machine in a concave like that, and that should give you enough clearance so that it doesn't hit. And you can see BMW's gone even further, and they've got quite a tight concave just in the corner there so that it's not fouling on anything. So need to replicate that and make it so it doesn't actually hit on the trailing arm. So as you can see, we've managed to achieve it. Does mean that we're changing to a Nissan stud pattern, but I don't have any problem with that because there's going to be a lot more wheels I can get. The only major thing that happened when we put this in is the studs ever so slightly hit on the trailing arm. So what we did was we gave them a bit of a slice. We did a straight slice so that we can remove the studs later, because I still think there's plenty of meat there holding those things in, and there's obviously 5 studs, which is one more than the 180 has. So we just did the straight dice. That means if I cross thread any of these studs, I can easily remove them and put new ones in. And because being a drift car, the wheels come off the back so many times, it's probable that at some point I'll probably cross thread one of those. So I decided to do it that way. You might decide to do it a little bit different, maybe work off a little less of the meat or leave a bit more of the meat rather than doing a straight slice. Or another option is you could possibly not even put in the hubs quite as far when you machine them up, and then do a spacer for the brakes so the brake caliper's still in the right place. Different options for different people. This is the one that I went with. So on the back here, you can see the back of the bearing and the back of the hub. The important thing here is to make sure that the hub is actually recessed in further than where the bearing sits, because what you want is the axle to actually be sitting up against the bearing, not against the hub, because when you put the hub nut on, if it's sitting up against the hub, it's not actually bolting and preloading the bearing, and you need it to be holding and preloading the bearing. So the hub is slightly machined a little shorter than the actual bearing, and so the axle actually sits against the bearing here rather than against the hub. So that's enough babbling from me about the parts we've had made up and the measuring we've done. Now's the fun/nervous part where we put it all together and see if it actually all works. I think we should be pretty good though. The only thing I'm not 100% sure about is the axle lengths. Obviously the axles can extend and compress, and you need them in a nice middle range of that motion at normal driving height and normal camber. But we need to make sure that they are in the nice middle section there, and also that adding camber that we might use on a road course when we're not drifting isn't going to affect that too much. So that might be the only thing that can trip us up. I don't really want to have to alter the axles. I'd really love to have just standard 350Z or 370Z axles. But we'll find out in a moment. So I'll put the GoPro on my head, show you guys us installing it, and see how we all work out. Yep, all right.
That makes sense here?
Yep. Spin it around.
certainly we probably need to get some seam spammers that are going to fit in there. Go and take that shot. Right, you got any bolts on you for that?
No, but we can find some, I'm sure.
So what I want to do is I'm going to measure how far I can push it in.
Yeah.
Because we know, I think it had like, was it 25mm or 30mm travel?
Yeah.
So what I want to do is just push it through its range and make sure it's either got some or it hasn't got too much.
Yeah.
It's just within its. You happy with that, wouldn't you?
Yeah, that's it there. So if I hold that, if I go like this now.
You'll be able to hold it in?
There you go.
Perfect. That's pretty good actually.
That's not too bad.
Oh shit, I was worried about that. This is actually the one that's worked. This is the one that actually could do with the space on the other side.
Ah, okay.
Oh, that's good. That's really good. So that there is 16. So that means that's got, we've used up 15mm there.
Yeah.
So we know on the other side it doesn't alter. So let's now.
Yeah. But as in when you go up and down, in that plane it doesn't alter.
It didn't alter. Yeah, because they got it around the arms. So the two arms are like that and it's there. So as it moves, it's basically running in the same arc. Yeah. That's why I wanted to check before, because when we did it from right down to the bottom to right at the top, it actually didn't alter. Yeah. So if it altered, I would have gone, well, we got to check the bottom and top. Yeah. But it didn't change range. What did I say? So it was from 32 to 16. That means it's moved 15mm. So that one was 12mm or something like that, wasn't it? As in from pull out to pull in? Yeah, that one was 12mm. So that means that one, I think it's got hips in the range. But let's just have a look at this now. Yeah. Something fits. We bought something and it fits. I'm not used to this. Don't get too excited. Yeah. Yep. No, that's pretty good to me. Actual progress. Sounds like we're getting somewhere. Yep. Big for that. So it's all in and goddamn I'm excited. Looks beautiful in there. I checked all the axle lengths with Dad. Or more like Dad checked all the axle lengths with me. And everything came up looking pretty good. It's right in the middle of the range, even on 3 degrees camber or 0 degrees camber. So very happy with that. Leaves lots of room for the axle to compress or expand if it needs to. Same on this side, all fits together pretty well. This axle's also pretty much perfect, so no complaints there. You can see how close the spare wheel area gets to the back of the diff. I don't think we'll be able to take this diff out in situ. We'd probably have to drop the cross member, but that's not really an issue because just 4 bolts, pull it down, and then it's that bit lower, you can get it out a fair bit easier. So that should be all alright. Like I showed before, the tail shaft to the gearbox all fits pretty well too. So very happy with that. And see how that all fits in the front. We have test fitted it with the little aluminium thing that goes from the front of the subframe into those bolts across there and down the other side, and that all fits well too. So very happy with that. Obviously we need to get the proper fasteners from Nissan to get all that bolted up, all the shafts and the tail shaft and all that sort of stuff, but I've got them on order. They just got to come from Japan. So here's some extra info for those that are going to be doing this swap. So now that we've got it all in the car, there's still 3 things that we need to think about in regards to finishing off the rear end. First thing is making sure that the nut that goes on the axle here actually tightens down onto the hub, because if you look in there, the actual splines of the axle come through, and it wouldn't actually tighten down if we had a nut at the moment onto the hub at all. So to fix that, we've got this. Basically what that does is it goes on there like that. It means that it goes around the splines and tightens down onto the hub. and you can put a nut on there to tighten it up. This one's a bit long. We're probably going to machine about half of that off. The machinist wasn't sure how long he had to make it. That sorts that. This is actually probably a bit long, so what we may end up doing is cutting that off, because what's going to happen is you're going to put a wheel on, and then this is going to have to stick out the middle of it, rather than having like a center cap. So what we'll probably do is slice it down here, and we'll use 2 nuts to make sure that it doesn't come loose. 2 nuts tightened up against each other, rather than using the castle nut and the split pin that the standard car used. The third and final thing that we need to think about is just a pretty simple one. Need to re-drill the rotors. Obviously, being a 330 trailing arm, I managed to get brakes with it at the same time. So I need to re-drill those rotors to the Nissan stud pattern. In theory at least, the machining that we did should mean that the rotor is the same offset as it previously was, so it should be able to just slide on there once we've drilled those holes, and the brake caliper should bolt up to it like standard. So they're the last little bits that we need to think about. Pretty much got them all sorted anyway, but yeah. So now I've got all the 370 gear in the car, sitting under its own weight. I got some Falcon stockies on there, just add that little bit of class. Overall, I'm really happy with how the car turned out. Being able to have a really strong rear end of the car is something that's quite important to me. And I think overall, I'm probably more happy having this in the car than I would be an M3 rear end, just because I know I can get parts. People at the track will have them, all the other bits and pieces that I already discussed. The other thing that I didn't think about previously though is I can actually shim this diff to be kind of like the one that's in the 180, because they're both R200s and use a very similar sort of LSDs. So should be able to shim that up nice and tight. Make sure that I got 2 tyre fire, but also with the 180 I noticed even though it's shimmed so tight that it skips in car parks, it doesn't have that front end push when you're doing grip that a welded diff has. So really overall quite happy with it, particularly because we were able to get standard 370z drive shafts straight into the car, no modifications necessary. So that to me was a big thing, because I didn't want to be spending, for 1, the money, or 2, the time that has to go into getting custom stuff made or spaces and all that sort of jazz. On the costing side of things, I don't know if I actually saved any money going this route, but that's probably mostly because I went down dead ends, spent time and money on things that didn't end up working or had to be reworked. So I think that's most of the reason. I think for you guys, now that I'm giving you the information, you should be able to do it a fair bit cheaper, or at least a bit cheaper than an M3 rear end. I'm really hoping that this gives you guys you know, all the information that you need to go and do this yourself. I've really tried to put as much detail into this video as possible so that you guys don't have to be guessing and working stuff out on the fly like I was. So if you do have any questions or anything that I haven't answered, feel free to put a comment, even if it's a couple of years after the video is posted. I'll try and get around to answering all of those. In the next video, I'm going to be reinforcing the floor of the car where the subframe meets it. That's a pretty weak spot on these cars. They've got lots of issues with it, so we're going to be rectifying that. Probably also building a bash bar for the rear, and a toe point or a jack point and bits and pieces like that. So that's in the next video. We've already started it. You might have seen bits and pieces in this video of that. We're trying to sort of do it all as one. Might get that out this year, we'll see. If not, start of next year maybe. But either way, have a nice Christmas, Happy New Year, and we'll see you on the other side with episode 6. If you've got a bobcat, you've got an engine crane. Why are you wet? What have you been doing around here that's wet?
Great on the 325 stuff. Stronger axles, stronger spline at the end of axle.
Oil takes
How much?
11 litres a motherfucker.
11 litres. Fuck doing an oil change. Apparently this is the motor that Dane's putting in his new 4-wheel drive. One of the 3 that he owns, I'm pretty sure. There's the engine donor. You're a little damp. You got the bit of the damp dog going for you. Yeah, I don't know how that happened.
Did you get a wet, mate? Did you get a wet?
No.